Hello, in this video I'm going to be going over how to solve radical equations. Now, these equations aren't really that much different than solving regular equations. You've got different kinds of radicals in there. So what you want to do is, number one, you want to isolate your radical on one side of the equation, which means get your radical by itself, because the whole purpose of getting rid of a radical is that you have to use the exponent that the radical has. So like this is a square root, so you have to use a squared to cancel it out. This is a cube root right here, so we cube it to cancel it out. Fourth root, we go to the fourth. So you're basically just using exponents to cancel out radicals. And then you just solve whatever you have left. At that point, it should be just like a linear equation. So what we're going to do, all right, like I said, so I'm going to go over some of these. I don't know if I'll go over all 10 in this video. Maybe I'll jump around a little bit. But what you want to do is you want to get your radical by itself, okay? So in this problem, we have the plus 5, so we need to minus 5 on both sides. So we get the square root of x equals 7. Now we have the radical by itself, and it's a square root, so we want to square both sides. And so x equals 49. And so this one's already done, right? Sometimes there might be something else with the x left that you have to solve. Let's look at this one real quick. This one's a fourth root. So we're going to go to the fourth power. So x equals whatever 3 to the fourth is, and I believe that's 81. So these first two, not that difficult. Okay, so let's look here. All right, so we got one like this, right? So again, we want to get the radical part by itself, so we subtract 10 from both sides. That gives us the square root of a plus 7 equals 1. Now we square both sides. Now 1 squared is still 1. But this cancels out with the radical, right? And then you've got a plus 7 equals 1. Now you might have to solve, another equation, like I said, a linear equation. So now, just subtract 7 from both sides, and we get a equals -6, okay? So, that's how you would do that problem. 4, you can try on your own. So, by the way, there's no practice with this. Like, this is literally it right here. So I'm not going to do them all. So 4 you can try. That's just like 3. Okay, 5 and 6. Actually, I'm going to show you 6, and you can do 5. If there's this fraction exponent, remember from the very first lesson of this unit, right? A fractional exponent means a radical. So since this is a 3 on bottom, this is just saying the cube root of 7p minus 1 equals -4. So if you want, I would just rewrite it as a radical like this, and then you can just solve it. I mean, you solve it the same way, cube both sides. 7p minus 1 equals -64, I think. I'm doing this off the top of my head. Hope that's right. And then you can just solve it from there. So, 7p equals -63 divided by 7, p equals -9. All right, so that's just what you do if you have something like that. For these questions, you can do both of these. You can still just divide, right? Divide by -2, divide by -2. To get the radical by itself. So you can solve that. For 9 and 10, okay, all you do is you have 2 radicals. That's fine. You're just still going to square both sides, and it's just going to cancel out both radicals, right? So it really just becomes whatever was inside the radicals originally. So x minus 8 equals 43 minus 2x. Now we want to solve this, so I'm going to add these x's over to combine like terms, and then I'm going to add this 8 over since I'm bringing the x's to the left, so that'll be 3x equals 51. Divide by 3, x equals 17. So for 10, you would do the same thing, except you just fourth both sides, but it doesn't really matter that much. So that's basically it. This is going to be a kind of an easy lesson. We're going to, kind of take it up a notch on Wednesday. Tomorrow you just have a graphing practice to do, but there won't be like any notes or anything since it's the SAT. So if you have any questions, let me know, and have a great day.